man continued to fight the force of gravity. Fighter aircraft were flagships in this battle. These particular aircraft were often the first to reach never-before-seen boundaries. The designers and engineers always had to tackle new, more complicated tasks. Facing the challenges, they often had to compromise and give away one thing in favor of another. Speed in favor of maneuverability, flight range in favor of operational load. But in the 70s of the 20th century, the new aircraft that combined at first sight the incompatible features was created. This aircraft was the Su-27, a representative of the new combat aircraft era. Oleg Samylovich was one of the originators of this plane. He was the head of the Sukhoi Design Bureau Concept Department in the 70s. The book of Oleg Samylovich about his work at his famous design bureau was published in 1999. One of the book parts is totally dedicated to the creation of the Su-27. This part is called The Best Fighter in the World. We decided to give the same name to our film. Before proceeding with the story of the Su-27 creation, we would like to dwell on the technical competence of the scientists and aircraft engineers and the scope of problems they were facing when they started to develop the new generation fighters. By that time, the military aircraft had more than 50-year experience of combat flying. Military aircraft were assigned a specific mission during World War I. Originally, airplanes were used for air reconnaissance. A bird's-eye view of the enemy lines made them clearly visible. The next quite logical step was using the aircraft for bomb dropping. Bombers became a real threat. This threat could be partly fought with anti-aircraft artillery. But small, biting like mosquitoes aircraft were much more efficient against bombers. This is how a special aircraft known as a fighter was born. To catch up with an enemy, a fighter aircraft has to fly faster. Speed is a major critical characteristic of a fighter aircraft. As soon as fighter-type aircraft emerged, most of the aerial combats became their privilege. Under such conditions, another important characteristic came to the fore: maneuverability. Speaking of fighters, it's an aircraft ability to place itself into a tactically advantageous position by means of fierce maneuvering in the air. Speed and maneuverability have always been principal characteristics of any fighter. A compromise between high speed and good maneuverability will be the main objective for aircraft designers. So what is the problem? Let's find out. The history of an aircraft is in many ways the history of its wing. As we know, a wing provides a lift force for an aircraft. For illustration purposes, let's study two aerodynamic layouts. One is a monoplane, an aircraft with one wing, and the other is a biplane, an aircraft with two wings. With the same size and weight, bigger wing area gives an aircraft better maneuverability. At the same time, bigger wing creates higher drag to an incoming airflow, thus reducing flight speed. It means that higher speed can be gained at the expense of maneuverability. In practice, the choice of an aircraft layout is affected by many factors. One of them is an aircraft structural strength. But we cannot think of the Su-27 as a biplane aircraft now, though during World War I, biplane layout was used to provide aircraft structural strength. Another important aspect is engines. The first aircraft engines could accelerate an aircraft to the speed of only 200 kilometers per hour maximum. In the 30s, the 300 kilometers per hour barrier was broken, then 400 and 500. Powerful engines, canopy cockpits, retractable landing gear, and finally monoplane layout were the attributes of high-speed fighters at the end of the 30s. Another critical test for military aviation was World War II. By that time, the monoplane fighters reigned in the air. Designers were looking for a compromise between speed and maneuverability within monoplane layout only. Aircraft outlines became more refined. The flight speed increased and it exceeded 700 kilometers per hour. That was the maximum piston engine fighters could achieve. Their era was coming to an end. The future was for jet engines. The young Boy Scouts are studying the new aerodynamics basics by watching this jet aircraft model. The small jet plane held by two steel cords is flying in circles with high speed. The new engines gave enormous opportunities for further developments. But as in the case with this model flying in circles, the two steel cords were preventing it from free flight. The new barrier was holding fighters' speed back. The problem was an aircraft wing again. With the speed going up, the air drag increases. It can be compared to an invisible spring compressing in front of an aircraft. At speed close to the speed of sound, the air becomes as solid as a wall. To get over this drag, a simple increase of engine thrust is not enough. It's necessary to significantly improve aircraft aerodynamics. Wing airfoil section was changed. A wing became thinner and swept. The speed issue was under intensive consideration again. 1,000, 1,100, 1,200 kilometers per hour, the sound barrier was broken. Engine thrust was increasing. Afterburners were developed. The flight speed was getting higher. The wings were continuously sweeping back. At the same time, wing loading was increasing. Fighters with a wing sweep angle of 60 degrees were the highlight of these developments. They were able to achieve double the speed of sound. Again and again, the critical speed issue is under consideration. But what about such an important fighter parameter as maneuverability? The maneuverability seemed to have been forgotten. In a way, it was true. To be more precise, it was not forgotten, but conscientiously sacrificed. In the mid-50s, they began to equip aircraft with air-to-air missiles. According to a new theory, aircraft could launch their missiles to attack each other from a long distance without engaging in close maneuver air combat. Fighters were treated as a specific platform to deliver and launch missiles. In America, one of the missiles called Genie was equipped with a nuclear charge. The designers intended this missile to explode in the air and burn to ashes every aircraft within a radius of several hundred meters. This missile wasn't used in real combat action. Moreover, the theory of aerial long-distance missile engagement didn't appear to be very successful. The war in Vietnam put it all into place. During the war, it was realized that shooting down an aircraft from a long distance was not always a success, and the aircraft got engaged in close combat conducted at subsonic speed. Quite often, the outdated MiG-17 was a winner against the latest supersonic but less maneuverable Phantom. It turned out that an aircraft could dodge attacking missiles using the so-called missile-avoiding maneuver. An aircraft could suddenly change its flight path, which a missile of those days couldn't do. Both the USSR and the US researchers came to a similar conclusion. A new fighter was needed, a fighter that could fly at high supersonic speed if required, and to steadily conduct a subsonic aerial combat. Which way to go? What aircraft type to choose? What concept to implement in the aircraft building? Those were very urgent issues to consider. We started a conceptual research on what aircraft had to be built. Everybody were convinced that a good maneuver was extremely important, since it is an aircraft maneuverability that plays a key role in aerial combat. So the problem was to develop highly maneuverable aircraft.
Возникла проблема создания самолета высокой маневренности.
There was another problem. A highly swept wing was low efficient at takeoff and landing. As a result, the takeoff and landing run was too long, and long runways were good targets for an enemy. Also, an aircraft may crash if its landing speed is too high. In the 60s, a new wing was implemented. It was a variable swept wing. Soon they started building combat aircraft with such a wing, both in the States and the Soviet Union. With a highly swept wing, an aircraft was able to perform a supersonic flight. With a mid-set wing, an aircraft could conduct an aerial combat. A straight wing significantly improved aircraft takeoff and landing performance. A variable swept wing was believed to be able to solve the problem. But this wing was somehow a link between past and future, a step toward new developments. A variable sweep wing was a good idea, but its designers had to pay a high price. Through the implantation of a variable swept wing, an aircraft weight was significantly increased. To make the next step forward, another solution, simple in shape and elegant in concept, had to be found. This very solution was implemented on the Sukhoi 27 aircraft. The general conception of the fourth-generation jet fighter was expected to use medium swept wing with a low wing loading. This was a way to improve maneuvering and takeoff and landing performance. So did the compromise aircraft high speed to its high maneuverability? Of course not. New generation engines allowed to achieve double the speed of sound, even with such a wing. This was a completely new approach to aerodynamics research, significant progress in engine building, a new fighter control system. Almost every field of aviation had its breakthrough. However, we are a bit ahead of time. Tactical specification requirement on an advanced frontline fighter was issued in 1971. The tender to develop a new fighter was shared between 3 design bureaus. These were Yakovlev, Mikoyan, and Sukhoi design bureaus. Till now, we were considering a fighter primarily as a flying vehicle. A fighter must definitely have a good flight performance, but this is obviously not enough. In order to become a superior combat system, a fighter needs up-to-date onboard equipment, armament, and many other things. It was a fighter updating where Pavel Sukhoi saw some problems. The general designer doubted that the Soviet electronics industry could provide up-to-date equipment for a new fighter. At that time, Soviet electronic equipment was quite heavy and big. The heavier electronic equipment is the heavier an aircraft is. In such a situation, to achieve required flight performance was far more difficult. It was also known that the American new generation fighter was already under development. The Soviet Union was behind the States in this race. It was necessary to design a fighter with the characteristic different from an American rival, so that it would be superior to enemy aircraft. It was that time that such a specific term as air superiority fighter appeared. A bench for two-fighter aerial combat was built for that purpose at our institute. The bench comprised two moving cockpits with all 3 degrees of freedom, though it was kind of conventional. However, the horizon was rolling and turning depending on all aircraft maneuvers and emergence of an enemy aircraft. According to the specification requirement issued by the militaries, the Soviet fighter characteristics had to be 10–15% higher than those of a new American fighter. It was also pointed out that to increase combat survivability of the new Soviet fighter, it had to be a 2-engine aircraft. At that time, the Soviet Air Force Commander-in-Chief was Marshal Kutakhov, and his deputy in weaponry was Colonel General Mishuk. Mr. Mishuk was a very experienced aircraft engineer. He served in the Army during World War II and was an educated and competent officer. Marshal Kutakhov was a combat pilot, here of the Soviet Union. He was always interested in technical aspects. He regularly attended meetings at the Ministry of Aviation Industry. He also visited the Institute very often to meet with our general designers. I remember he used to call us once a month and asked, "Well, science man, have you got any news?" The military people treated us very well. They had a big stake in the 4th generation fighter concept. In those times, a lot of money was spent on aviation projects. The country leaders, headed by Leonid Brezhnev, spared no expense on aircraft and other military projects. The Communist Party leader was looking at displayed combat equipment with evident pleasure and genuine interest. It was common practice for leading aviation designers and military command authorities to participate in such displays. Pavel Sukhoi, wearing his famous hat, is on the left from Leonid Brezhnev. Pavel Sukhoi started his aviation career at the Central Hydroaerodynamic Institute, where he worked under direction of Andrei Tupolev since 1925. With his direct involvement, Pavel Sukhoi designed I-4, the first Soviet all-metal fighter, and I-14, the world's first high-speed monoplane fighter with retractable landing gear. The Sukhoi Design Bureau became independent in 1939. This year, mass production of the BB-1 short-range bomber designed by Sukhoi was started. In 1940, this bomber was named Su-2, and it became the first aircraft which received the famous Su name. Since that time on, combat aviation is inconceivable without Sukhoi aircraft. In the 60s, fighter aircraft designing was a real success for the Sukhoi Design Bureau. These were the aircraft of 2 types: fighter interceptor and fighter bomber. It was the Su-17 fighter bomber that became the first Soviet variable sweep wing aircraft. Another interesting subject matter in the Design Bureau from the early 60s was creation of the T-4 Sotka aircraft. Creation of this aircraft allowed moving to quite a new level of all the Sukhoi Design Bureau activity, despite the fact that the aircraft was not put into mass production and the project was stopped in the mid-70s. However, this project laid the scientific and technical groundwork that was successfully used later on in creation of the new generation aircraft, including the Su-27. In March 1971, the meeting of Aviation Ministry Scientific and Technical Council took place. At this meeting, 3 design bureaus presented their groundwork on the new advanced fighter. The Yakovlev and Mikoyan projects outwardly looked like the previous aircraft they built. But Sukhoi presented something new. That was a project of the future Su-27. Research work on this aircraft was started in 1969. The originator of the project was Oleg Samylovich, who worked in the Design Bureau Concept Department. By that time, he took part in such projects as the T-4 long-range missile carrier and the Su-24 frontline bomber and the Su-25 attacker. Now, it was a new aircraft turn. The designers had to place the emphasis on the integral layout of the future fighter. The Su-27 also started with Oleg Samylovich. One winter Sunday in 1970, the aircraft layout was created with his hand. On that Sunday, Antonov, Samylovich, and me were working in the office. A day before, on Saturday, Bondarenko was there. All of us wanted to consolidate the achievements made by the team at that time, mainly on Antonov's drawing board. There's a profession dealing with the aircraft pre-designing. This is a work on an aircraft when it is not yet available. Samylovich liked to say, "What is designing? Is it a science or art?" It is both a science and an art. The success of an aircraft design is in fact the status of its designing school. I was lucky to be the person whose drawing board had that aircraft drawn upon it. It's true, but on the other hand, all personnel were behind my back, so to say. Many people from the staff contributed their thoughts to this aircraft and its elements. There is no doubt it was an exciting time. Being young specialists, then we were mainly impressed with the faith they had in our capabilities to work on such overwhelming projects. There were older friends who treated us as their equals, or it might have seemed to us. On the other hand, youth is the best time for everyone. I have the best recollections of that time. After the wind tunnel tests of these models, upon receiving positive results, Oleg Samylovich said, "Vladimir, let's go to Sukhoi." Sukhoi rose from his seat near the table, shook my hand, and gave me a paper where it was written that Vladimir Antonov, designer-engineer of the second category, was awarded the first category with a salary of 185 rubles. The most interesting were the words that Sukhoi said. "Young man, you've done a lot of work, but you have to understand that this is a part of the work being done in the country to conquer this peak, to develop the fourth generation fighter." So what's the feature of the layout that the designers offered? Let's have a go at this problem. To fly up in the air, an aircraft needs a lift force. A wing plays a key role in this process. There are some specific ways to create a lift force on the wing. These are use of special airfoil section and an increase of an angle of attack. The angle of attack is the angle at which a wing meets an airflow. In these airflow conditions, air pressure under a wing is higher than above it. This pressure difference creates a lift force on the wing. But what about other parts of an aircraft? Do they create a lift force? What about a fuselage? On most aircraft, fuselage creates a minimum lift force. Is it possible to change the situation? It appeared so. The Su-27 designer used airfoil sections to build other structural parts of an aircraft, not only a wing. It would be no exaggeration to say that the whole aircraft became a lift surface. A wing root glove played a large role in creating lift force. But initially, the designers could not see all the advantages of such technical innovation. They thought of a wing root glove as a method to improve aircraft stability at supersonic speed. Only after an enormous amount of wind tunnel tests, the designers realized new advantages of the wing root glove. We had a wonderful guy, Kurichkin, from Roman Irodov's department, who discovered one very interesting effect. If the wing root glove is made pointed, which means that the tip is sharp, a very powerful vortex was induced with this sharp tip. This effect made it possible to increase lift force by at least 50%. Pointed wing root glove transforms an airflow into a powerful air vortex. A vortex creates a stable vacuum zone above the wing. Differential pressure grows, causing a significant increase of lift force. With an angle of attack increase, the vortex intensity grows. This allows an aircraft to fly at higher angles of attack without losing its stability or stalling into a spin. This directly leads to higher maneuverability. For example, a turn or a combat turn can be performed more aggressively. During such maneuvers, the vortex intensity is so big that a vortex can be seen with the naked eye. It's time to have a look at what was happening with the new American fighter. In July 1972, the aircraft called F-15 Eagle performed its first flight. The F-15 had a traditional layout. Therefore, the Su-27 aerodynamic layout had advantages and was expected to be superior to the U.S. fighter. But Su-27 had to meet a competition in the USSR first. The choice had to be made between the Yak-45, MiG-29, and Su-27. It's worth mentioning that the Sukhoi Design Bureau presented another project of a fighter with traditional layout. The Sukhoi designers preferred their new layout to the traditional one, but they couldn't predict the opinion of the military authorities on the issue. But the future of the new layout was so promising that at the next stage of the tender, the MiG-29 took a new shape. It's worth stressing that it was planned to choose only one project. But later, some essential correction and changes were made into the plan. This situation somehow looked similar to the one they had in the U.S. Designing their F-15 aircraft, the Americans realized that sometimes it was not reasonable to use such an expensive aircraft. Therefore, in addition to the F-15, it was decided to develop an aircraft which would be cheaper and lighter. In future, this aircraft will be known as the F-16. In the Soviet Union, the concept of an advanced fighter was also revised. Eventually, the Mikoyan Design Bureau had to develop a lightweight fighter. Heavy fighter development was the task for the Sukhoi Bureau. As for the Yakovlev Design Bureau, they didn't participate in this tender any longer. The decision to design two different fighters was quite logical. It wasn't copying of the American conception at all. In the USSR, they conducted certain research on this issue. The results were nearly the same. Lightweight fighters such as the MiG-29 were required to provide air defense over a battlefield. Heavy fighters like the Su-27 had to win air superiority operating over enemy territories. That would ensure successful combat mission of a frontline attack aircrafter. It's worth mentioning that in the process of the aircraft building, the question whether we were right in our decision for the two aircraft types was continuously emerging. By the time when Dmitry Ustinov became Minister of Defense, he raised this issue at the moment when we were on the state flight tests. Anyway, we stood this strong administrative pressure and proved that it was necessary to build two aircraft. They were the MiG-29 and the Su-27. In 1974, Naum Chernyakov was appointed the aircraft chief designer. At that time, the name Su-27 was classified, and the aircraft was developed under T-10 designation. From the early 70s, a lot of tests and experiments were conducted under this project. These included wind tunnel simulation, tests on full-scale flying models, test bed for the aircraft systems development, and many others. The Soviet leading aviation institutes were also involved in this project. With the development of Soviet aviation, more companies and enterprises became involved in the new aircraft creation process. Among those were different design bureaus and research organizations of various trends. Speaking about that time, it was normal and very intensive work. I can't say that it was easy, as it was very intense, but quite normal work to do. When we first saw the T-10-1 aircraft mock-up, we were very much impressed with its unusualness, aerodynamic configuration, and with all of its shape. The aircraft looked like a bird. Without any exaggeration, I would say in those years I was looking forward to a new working day, because it was interesting to work. Now there is some talk about stagnation period. Stagnation might have been somewhere, but in the defense industry, we were in the state of war. We worked under wartime schedule. That was an epoch when employees of the defense industries were leaders and were supported, including financial support first. There were some difficult situations, however. We were not pushed and beaten, but were given help to set something right. That was a great era. The objective was clear. The Soviet fighter had to be better than the American one. Soviet better than American was sort of official slogan in the USSR. Now let's go back to the 70s. The Olympic Games in Munich in 1972. The Soviet athletes had a goal to win 50 gold medals and to outstrip the Americans in this competition. No sooner said than done. The Soviets won 50 gold medals. Those victories were unforgettable. The USSR men's basketball team won their first Olympic gold medals by beating the US team in a challenging and dramatic game. Athlete Valery Borisov won 100 meters and 200-meter runs and cut short domination of American sprinters. The Soviet power must be kept high. In 1975, everything was ready to build prototype aircraft. In 1976, the Council of Ministers of the USSR issued a corresponding decree. In spring 1977, the first T-10 prototype was ready for flight tests. Unfortunately, Pavel Sukhoi didn't live to the moment to see the aircraft completely built. On September 15, 1975, this outstanding designer passed away. His close associate, Yevgeny Ivanov, took over. Here is the video of Tushino Air Parade in 1948. Pavel Sukhoi is in the middle. Yevgeny Ivanov is on the left. The Su-27 chief designer was also replaced. In 1976, this position was taken over by Mikhail Simonov. May 20th, 1977. Flight Research Institute Airfield in Zhukovsky. The test pilot, Vladimir Ilyushin, is getting ready to take the new fighter up into the sky. Vladimir Ilyushin is hero of the Soviet Union, the Sukhoi Design Bureau senior test pilot, and a son of the famous Soviet aircraft designer. He tested many Sukhoi aircraft before that flight. Had he got a feeling that this aircraft would become one of the best fighters in the world? Before this aircraft, I flew 142 modifications of different aircraft. I always had a feeling that I was a kind of smarter than the machine, capable of doing more than it could. But the things were quite different on that 143rd. It proved to be smarter than I was. As soon as the aircraft took off from the concrete, taking the aircraft into the air for the first time, I realized that this aircraft could do more than the pilot. To make full use of its wonderful capabilities, it's necessary to improve my skills. It was an aircraft that could be awaited all life long. For the sake of this aircraft, it was worth becoming a pilot. But it was a very long way to make this aircraft the best world's fighter. By the time of the first test flight, despite all the technical innovations, it was evident that this aircraft could not be superior to its American rival. The F-15 already showed its potential. In 1975, the specially arranged aircraft set several rate-of-climb world records. During the Su-27 development, it became obvious that the aircraft would be too heavy. Its weight characteristics were exceeded because of heavy electronic equipment. Pavel Sukhoi was right when he doubted that electronics industry could provide up-to-date equipment. Missile armament designers also fell outside the limits. The engines were only in development stage, but it was clear that they could consume more fuel than expected, and therefore more fuel will be required on board the aircraft. There were also problems with the aircraft aerodynamic parameters. During the first flight test, it turned out that angles of attack higher than 10, the aircraft started to shake. In such a situation, it was useless to talk about the Soviet fighter superiority. The global confrontation between the Soviet Union and the USA forced the two countries to constantly improve and increase their military capabilities. The best minds on both sides of the Iron Curtain were involved in the creation of new different types of weapons, be it small arms or ballistic missiles. Sometimes one country was taking a lead in this armaments race, sometimes it was the other. The United States, as an example, left the USSR behind in developing the fourth-generation fighters. Then was necessary for the Soviet Union to catch up and outdo America. But when almost everything was ready for the new Soviet Su-27 fighter tests, it turned out that this aircraft could not be able to surpass its opponent, the American F-15 fighter. To change the situation, some urgent measures had to be taken. Many could foresee that scenario. In the Sukhoi Design Bureau, the aircraft chief designer, Mikhail Simonov, was the initiator of deep upgrading. But the final decision was made by the general designer of the whole design bureau, Yevgeny Ivanov. Over 30 years he worked for the design bureau and remembered all its milestones, including the time of the temporary closing. At that time, some strict measures could also have been taken. The more so because by that time, one ambitious project of the design bureau, the T-4 missile aircraft carrier, was stopped. A lot of money was spent on the Su-27 as well. At Komsomolsk-on-Amur aircraft plant, they were ready to start mass production of the fighter. And now, the aircraft was proposed to be made almost anew. To take this decision was extremely difficult. On the one hand, everything was well organized. The project was in full swing. Moreover, the draft drawings were issued and sent to Komsomolsk-on-Amur for production. To put it straightforwardly, we actively began working on that project and worked with great enthusiasm. All the personnel were involved in the Su-27 project. However, further decisions had to be taken. As a matter of fact, it's not a challenging task to put a modern fighter into mass production. I think that was often the case in the history of our aviation. We believe everything goes well, but the aircraft is at a medium level. Eventually, we began to produce these aircraft. Suddenly, in 1978, we learned that was the end of it. Both the chief engineer and chief technologist remonstrated against it. A lot of work, and it all came to nothing. If we design a new combat aircraft, there's only one way for us: to design an aircraft to defeat an enemy. If we are unable to design an aircraft capable of defeating an enemy airplane, then we have to take drastic measures. Either shoot ourselves, or such losses are losses of national value. Therefore, we could have made only a better aircraft as compared to the American one. The first impression or first response was like, "Why have you overlooked?" "What were you thinking about?" Followed by the question, "What has to be done?" "I visited the design bureau. Mikhail Simonov convinced me. We had to defeat an enemy." But, unfortunately, the aircraft was unable to defeat it. When an aircraft is already in production at the plant with a lot of money spent for equipment, all technological processes, one has to be a very brave man to change an aircraft design at that stage. Mikhail Simonov took a decision to do so. The Minister of Aviation Industry at that time, Mr. Silayev, gave his assessment of the most negative side of this decision. When we finished the talks and the decision to redesign the aircraft was taken, he said, "Mikhail, you are lucky it is not 1937 now." Had they closed the Sukhoi company, it could have been a disaster. But at that time, it was not difficult to solve some problems with the designer and the production plant. That time, everyone was eager to make positive decisions. Well, formally, the aircraft met the requirements. There was no doubt about that. Of course, it met the requirements. The design bureau is quite competent, and the designers are knowledgeable. They did their job well. But what I'm saying is that its maneuverability was not the same as we can see it now. The redesigning process was caused by certain factors. Some aircraft parameters were not sufficiently high. But now it is not so important. Most importantly is that the designers had an unexpected opportunity to analyze the initially developed rather than successful project and reconsider some accepted engineering decisions. Within the shortest time frame from November 1977 up to January 78, they succeeded in improving the aircraft performance. So what was done to improve the aircraft performance? The decision was made to stick to the general concept, the aircraft integrated circuit, where the wing with its wing root glove and fuselage forming a single lifting body remain the same. Here on the left is the aircraft of initial design. On the right is a new aircraft. As we can see, they look very similar. However, this is where the similarity ends. To achieve the required speed and flight range, it was necessary to reduce the aircraft aerodynamic resistance. With that end in view, they changed the engine unit's position. Now the engine nacelles created less drag. Outlines of the fuselage nose section were changed as well. The landing gear design was changed. It became more compact in its up position. After aerodynamic and flight tests, the optimum layout of the fins was chosen. To get the required flight performance, maximum effect was expected from the aircraft wing. On the aircraft of the previous design, the wing had smooth lines. All of us might have underestimated the aircraft behavior at high angles of attack. As soon as Ilyushin flew the aircraft, he immediately said that the angle of attack increased by 6, 7, 8 degrees would lead to wing vibration. The new wing obtained its evident tapered form. The wing leading edge was equipped with droop leading edges. When the angle of attack changes, these droop edges automatically deflect. This helps to improve the aircraft's stability at high angles of attack and to increase its lifting performance. The most interesting is that at these particular angles of attack, the drag decreased. Less thrust was required for making a maneuver. So the effect appeared to be amazing. The trailing wing edge was equipped with a new flaperon control. Standard trailing edge includes a flap and an aileron. Providing maximum lift force at low speeds, the flaps work at takeoffs and landings. Ailerons are used for aircraft lateral control. So a flaperon is a single control, functioning both as a flap and aileron. As a consequence, less weight and better structural stiff. Other aircraft structural components were also changed. The front undercarriage was moved 3 meters to the rear. With all these changes, the engines were protected from foreign objects. For the same reason, protective screens were installed on the engine's air intakes. They work in automatic mode during takeoff and landing. The screen is a titanium panel which consists of 100,000 square cells, with a size only 2.5 millimeters each. In the initial version, the air brakes were installed in the bottom part of the aircraft fuselage. With extended air brakes, the aircraft began to vibrate. To eliminate this vibration, the air brake was installed on top of the fuselage. The new air brake installation required redesigning of the cockpit canopy. Instead of sliding backwards, it opened upwards. This change provided safe canopy release trajectory during ejection with an extended air brake. Another important improvement was an increase of the total number of missile suspension points from 8 to 10. As a result, there were so many improvements that one could call it a new fighter. The aircraft had a factory code T-10S, where S stood for serial, though the official name of the fighter remained the same, Su-27. As to the aircraft of the previous design, it was decided to use them for versatile tests. One chief designer relieved another during the working process. In 1979, when Mikhail Simonov quit for the Ministry of Aviation, his position was taken over by Artyom Kolchin. In 1981, Alexei Knyzhov became the chief designer. As for Simonov, he returned to the design bureau in 1983 as general designer now. On April 20th, 1981, the new aircraft made its first flight. The fighter was piloted by test pilot Vladimir Ilyushin. The first flight is an outstanding, even a festive event for an aircraft followed by everyday work. Before an aircraft comes into service, it must be tested for strength, in the direct meaning of the word. Chronicle of aircraft tests is always full of both victories and disillusions, and sometimes even tragedies. A bad flight accident happened in December 1981. At the speed of 2,300 kilometers per hour, the nose of the fighter fuselage was destroyed. This flight was the last one for test pilot Alexander Komarov. Before that event, in the 3 previous flights, when we went to high Mach number, pilot Alexander complained of some noise behind the seat back. The tests were suspended, but later the human factor played its role to make one more flight. It happened in the winter on December 22nd. We had been looking for him for quite long. The helicopter pilot saw the top of one of the fir trees all snow-covered with a trace going down. We arrived in that area and found him. He was sitting there in his seat. Tests are quite a challenging period for an aircraft life, requiring confirmation of all data set and specifications. A lot of things happened. We had to artificially bring the aircraft into difficult modes, achieve crazy G-loads, to play, I would say, with a power plant, driving it into conditions when it had to fail. The tests were going with difficulties, as it was not often the case to test the totally new aircraft. As a rule, about 10 to 20% of the innovations are used. On that aircraft, everything was new. Nikolai Sadovnikov faced some specific situations. In one of the flights at extreme strength test modes, part of the aircraft wing was destroyed. The aircraft was turning and shaking at a very high speed, but he settled the aircraft down. Nikolai's high skill and self-control could be envied in this respect. As the song goes, he flew with one wing and a prayer. In 1982, we actually completed the main test stage. Everybody was satisfied with the results, though we had a lot of pressure to meet the time schedule. At that time, they could urge the people involved in the work, and that was a right thing to do. When the first stage of the tests was over, military test pilots got involved into work. Extreme modes again and again. In cooperation with the military, the most efficient layout of the cockpit instruments, devices, and switches was determined. A pilot must feel comfortable at all flight stages. There were some disputes as well. Up to now, a pilot performed ground wheel braking manually with an aircraft braking handle. We switched over to pedal braking. The pilots did not accept that. The unanimous response was no. They were all for the old braking procedure. Chirkin was the leading test pilot from the military. When he arrived, he said, "Just wait, I'll arrange my team." They had been discussing something for about an hour. We were not there. They squabbled and debated. He came out and said, "Don't change anything. You made it better." Alongside with the flights, ground tests were conducted. For a short run here on the ground, an aircraft was exposed to such loads that this fighter would experience during long years of its service life. The purpose of all tests is to find all the flaws, to find and to fix. In 1985, the fighters became operational in the Air Defense and Air Force squadrons. The Su-27 single-seat frontline fighter, aircraft length 21.9 meters, height 5.9 meters, wingspan 14.7 meters, maximum takeoff weight 28 tons, maximum flight speed 2,500 kilometers per hour, flight range 3,900 kilometers, service ceiling 18.5 kilometers, limiting G-load 9. The first comments of the Air Regiment's pilots confirmed the outstanding performance of the aircraft. With its combat efficiency, the Su-27 was superior to all previous Soviet fighters. We immediately got a feeling that this aircraft is simple and easy in flying. It has high maneuvering characteristics, and what is most important for a pilot are the new requirements for pilot physiology and physical capabilities. A pilot has to stand such G-loads so that to use all maneuvering characteristics of the aircraft. I remember at that time, I seemed to have been dreaming of a similar aircraft, but it appeared to have exceeded all my expectations and dreams. It was time for this fighter to become well known all over the world. In 1986, a special aircraft was prepared to set up world records. However, at that time, the Su-27 was still a classified fighter, and that special aircraft got the name P-42. We were told that the Su-27 name was not good for the record flights. Our program would be approved and signed, but the aircraft name should be changed. I proposed to take the first letter, P, of my father's name, Pyotr. During World War II, at the time of the Stalingrad battle, he worked at headquarters in a political department of the 66th Army and died there. It was 1942, the year of the victory in Stalingrad battle. The aircraft name was changed to P-42. Like any aircraft designed to set world records, the P-42 was stripped to minimum weight. It was made as light as possible. Even the paint was removed. This was common practice. The Americans did the same when their F-15 was setting rate of climb records. Moreover, they set up those records in wintertime, when at the low temperatures, the engines developed maximum thrust. Now it's worth mentioning another important feature of the fourth generator fighters, such as the Su-27 and the F-15. The thrust-to-weight ratio of these fighters is more than 1. That means that the engine thrust exceeds the aircraft weight. The power plant for the Su-27 aircraft was developed in the Arkhip Lyulka Design Bureau. By the time of its development, the Bureau had glorious chapters of history. The first Soviet turbojet engine was developed in the Design Bureau in 1941, before the Germans started to invade the USSR. After the World War II, the engine designers began to collaborate with the Sukhoi Design Bureau. Most of the Sukhoi aircraft were equipped with the AL Arkhip Lyulka engines. There are two AL-31F turbofan engines installed on the Su-27. Their total thrust in full afterburner is equal to 25 tons, while the aircraft normal weight is 23 tons. So the aircraft thrust-to-weight ratio is more than 1. As compared with the previous generation fighter, this parameter was 0.8. As to the special record aircraft, as soon as it became lightweight and the thrust was maximum augmented, its thrust-to-weight ratio at takeoff reached the value of 2. This enormous ratio led to a problem. The brakes couldn't hold the aircraft at the start. Therefore, the aircraft was tied with steel cables to a heavy tow truck. We selected an afterburner, but this tow tank couldn't hold the aircraft. Then we had to find a huge mountain bulldozer at the airfield. I don't know what it was doing there. The bulldozer plowshare rested against the tow tank with some props under it. and only this system could hold the aircraft when activating the afterburner. When the pilot activated afterburners, the cables were detached and the aircraft rocketed up into the sky. The aircraft was reaching the sound speed climbing vertically. From 1986 to 1988, the P-42 set up more than 30 world records. Test pilot Viktor Pugachev reached an altitude of 3,000 meters in less than half a minute. To be more precise, in 25.4 seconds. It is 2 seconds faster than the world record of the F-15. Whereas Nikolai Sadovnikov climbed to an altitude of 15 kilometers in his aircraft within 1 minute 16 seconds, which is 7 seconds faster than the Americans did. So the Su-27 was a winner in the first stage of the long-distance run against America. In the early 90s, the chance to perform demo aerial combats between the Su-27 and F-15 became real. In 1992, pilots of Lipetsk Aviation Center made a friendly visit to Virginia U.S. Air Force Base. The first air combat, we met and had a briefing who should fly to the tail first. It was agreed that first they are ahead of us, we are behind. They tried to maneuver, but nothing came of it. Then we changed the rules. I fly forward, and the American pilot, the squadron leader, is behind me. From this position, I have to fly away from him and go to his aircraft tail. Then it was considered a victory. He is deliberately in a wonderful position with the only task to hold it. I drag him higher up, making an accelerated combat turn while climbing. He is following me, losing speed within the limits of less than 650 kilometers per hour. And then the Su-27 aircraft has a total advantage. After 1.5 turn, I fly to his tail. There is nothing that he can do. We later talked with the Americans. Their general flew the Su-27 two-seater with our general. When he got out of the aircraft, he was delighted. When we came up to him, he straightforwardly admitted, with his thumbs up, it was better than their F-15. Foreign specialists got their first impression of the new Soviet fighter exterior in 1977. In this picture, made from the American reconnaissance satellite, the smooth contours of the T-10 prototype airplane can be seen. But at that time, they couldn't get a clear and complete picture of the new aircraft. By the way, the NATO code name for the Su-27 is Flanker, which literally means flanking. The word is pragmatically neutral. It's just that under NATO classification, all Soviet fighters' names begin with the Latin letter F, which stands for fighter. In 1987, only 10 years later, the NATO pilots finally made detailed pictures of the Soviet flanker when these fighters began patrolling the open sea. Two years later, the Soviet Su-27 demonstrated its capabilities in the skies of Western Europe. In June 1989, the regular international air show took place in the French city of Le Bourget. To this day, the Soviets brought only civilian aircraft to international air shows. But in 1989, according to the new political course of the USSR leaders, considered it possible to demonstrate military aircraft as well, including the Su-27. The fighter was presented in two versions. One was a basic single-seat aircraft, and the other, Su-27UB, was a two-seat combat trainer. Both fighters flew non-stop from an airfield in Zhukovsky, Moscow region to Le Bourget. More than that, they flew without air refueling and external fuel tanks. This spoke volumes about the capabilities of the aircraft. As to demo flying, it was a real shock for all foreign aviation specialists. One of the maneuvers performed at Le Bourget by test pilot Viktor Pugachev was called Pugachev's Cobra. It's worth noticing that the Americans were the first to perform maneuvers similar to that one of Pugachev. It happened during F-14 fighter test flights in the early 70s. But the maneuver amplitude didn't exceed 90 degrees. When performing Cobra, it reaches up to 110 degrees. The possibility of performing such a maneuver was theoretically proven by Central Hydro Aerodynamic Institute specialists. By the way, the scientists call this maneuver dynamic going into extremely large supercritical angles of attack. For the first time, similar modes were reached at the Flight Research Institute in Zhukovsky, where the Su-27 was tested for stalling and spin. During one flight performed by test pilot Igor Volk, it was proved that the aircraft doesn't stall when going into supercritical angles within the shortest time. Using all theoretical and practical results, the Sukhoi Design Bureau prepared the new aerobatic maneuver for demonstration. As a result of this maneuver, the aircraft energetically brakes within 4 or 5 seconds, reducing the speed by around 250 kilometers per hour. There is no other possible way to brake an aircraft by such a value. The aircraft demonstrated its great capability. I believe the specialists and spectators will estimate it at its true worth. In the beginning, the perception was like some Russian bears arrived on a big airplane. What are they going to demonstrate to us? However, all this was quickly dissipated. Aviation specialists from many countries I had a chance to talk with undoubtedly stated that we really received the mode no other aircraft is able to perform at present. It may be the future. A special interest was displayed to us. It was the USSR at that time with its classified aircraft, and suddenly Europe was witnessing quite a marvelous achievement in the aircraft building branch. We were pleased with that. During all meetings that took place, we proudly stated that we were not from the country of bears. In general, we can do something. The concept of longitudinal static instability is implemented on the Su-27. To a large extent, this concept is an evidence of the aircraft's high maneuverability. Let's have a closer look at this concept. An aircraft, like any physical object, has a center of gravity. Relative to this center point, an aircraft in the air behaves as a peculiar swing. There's another point, the point of aerodynamic center. When the center of gravity is in front of the aerodynamic center, the aircraft is statically stable. Suppose that in flight, such an aircraft experiences external disturbance. It can be a wind blast trying to lift an aircraft nose up. It creates a lift increment at the other side of the swing in the point of aerodynamic center. This lift force tries to push an aircraft to its original position. This is happening without any actions from the pilot. Therefore, stability is a capability of an aircraft to restore its flight mode by itself after it is affected by disturbance. Such ability is very helpful when it comes to trainer aircraft. A stable aircraft itself can correct mistakes of a novice pilot. The Su-27 is statically unstable. It means that its aerodynamic center is in front of the aircraft's center of gravity. In this case, a lift increment doesn't prevent an angle of attack from increasing. Specialists call it loss reduction for the aircraft balance. Practically, it means that an aircraft is more stable when it comes to combat maneuvering modes. On the other hand, to control such unstable aircraft manually is quite challenging. On a statically unstable aircraft, a pilot has to make double movement. He has first to increase an angle of attack and then to balance the aircraft. Not to mention the fact that any disturbance of an airflow will continuously take the aircraft away from the balancing point. It means that he has to catch it all the time, especially at high rams, and the fighter ram is 10,000. That's a disaster. A pilot can easily lose the aircraft and go to a destructive G-load. Strange as it is, Brothers Wright airplane, for example, was statically unstable. They had to balance it manually all the time. Generally speaking, it was impossible to fly this airplane in a standard way. Flying it was a kind of circus art. The subsequent airplanes were designed stable so that the pilot wouldn't have to care about this process. Here we again returned to this idea of instability, when automatics, control system, hydraulic drives, hydraulic system give a pilot better control to his unstable aircraft. This system which helps to control an aircraft is called fly-by-wire system. At the dawn of aviation, a pilot controlled an aircraft with the manual controls. The pilot had to be physically fit to perform these manipulations. The same control was used in the first jet aircraft. But in the course of time, aircraft were getting heavier, their flying speed was going up. No man could control such an aircraft with his muscles. Therefore, they began to equip the aircraft with hydraulic actuators, thus reducing the physical load for a pilot. In the 70s, they decided to reject mechanical connection. It was replaced by electrical impulse. At the time when they started to create the Su-27 aircraft, this system was big news. In the West, it was called fly-by-wire system. There was a lot of talk about it, but nobody used the system. For the first time in the world, this system was used on the aircraft Sotka. You might have heard about it. It gave us a lot of confidence, great experience, because the main principles were implemented on Sotka aircraft. Therefore, when the Su-27 creation was started, they also made a decision to use fly-by-wire system. On the Su-27, when a pilot deflects the control stick, fly-by-wire system computer forms an electrical signal which, in its turn, controls the hydraulic actuators. Depending on flight conditions, such as altitude or speed, the system reacts differently to the pilot's actions. But a pilot must have a feeling of controlling his high-speed aircraft. For that reason, the system is connected to these special loading mechanisms. Depending on the situation, a pilot applies different force. At extreme modes, the control stick prevents the pilot from making a wrong move. As an example, let's consider a bicycle. It has direct control. The wheel turns as far as the handlebars are deflected. I think if we make a smart bicycle, it would operate according to the principles implemented on a smart aircraft. The handlebars are maximum deflected as sharply as you want, incommensurably to how you are riding, and the wheel must deflect at no more than a possible maximum from a safety point of view, in order to maintain the balance. When external disturbance, such as the above-mentioned wind blast, affects the aircraft, the control system will put the fighter back in its initial position. To teach the system to properly respond to change of situation, lots of flight tests were conducted on the first T-10 aircraft. Unfortunately, one of these flights came to a tragic end. That day, July 7, 1978, the fighter was piloted by a hero of the Soviet Union test pilot, Yevgeny Solovyov. On this video, he is second on the left. According to the flight task, Solovyov had to push his aircraft hard to extreme G-load and then put it back to original position. They call it an impulse. He had to quickly pull the control stick and then immediately push it back. In this situation, some defects of the aircraft control system became evident. The aircraft nosed up too fast, and the G-load momentarily went to 6. Solovyov did not expect it to be more than 2. As a reflex, he pushed the control stick back. The aircraft rushed down. Then another reflex action. The G-load was exceeded, and the aircraft was destroyed in the air. Yevgeny Solovyov died. We took the tragedy very hard. We were very much upset about it. The aircraft crash was caused by some new phenomenon. Later on, we found and overcame the phenomenon, but it took some time. To be brief, we have encountered the new problem that cost the life of our best pilot. Not to mention that he was an honored test pilot. Hero of the Soviet Union, a pilot of the highest professional skills. Unfortunately, life is such as it is. Death of our pilots Komarov and Solovyov during flight tests is for the aircraft Su-27 and its modifications to fly and become better. It may be a sacrifice without which it is impossible to achieve the aircraft's ultimate recognition and put it into service. We continued the work and developed the aircraft to high airworthiness, put it into service, and take pride in that. We always remember our friends when speaking about this aircraft, as well as the other ones, because their contribution to the initial stage and beginning of tests can scarcely be overestimated. A test pilot's work is not easy. When it's time to meet the unknown, they are always the first to face it. While making this film, we were asking the pilots to describe their impressions when they first met the Su-27 fighter. Each and all pointed at excellent maneuvering characteristics of the aircraft and its combat capabilities. Many favorable comments were made on the outward beauty of the aircraft, and even the impressive dimensions of the fighter excited certain emotions. Almost every pilot, when recalling his first flight on the Su-27, was quoting as an example the words of the test pilot Vladimir Ilyushin. Vladimir Ilyushin once said that he flew the aircraft which was smarter than him. These are very true words. I recall his words when I flew this aircraft myself. The feeling was exactly the same. It felt like the aircraft flew itself, and the pilot didn't have to make any actions. Due to the fly-by-wire system implementation, this aircraft became very smart, as many pilots like to say. Test pilot Vladimir Ilyushin, who was the first to fly this aircraft, used to say that the Su-27 was smarter than a pilot. I definitely agree with Ilyushin. When I started to fly this aircraft, I felt the same way. When a pilot flies a new aircraft, he tries to feel it, tries to become a part of it. If you're able to feel your aircraft, then you can analyze your actions and the aircraft capabilities, which is very important. Only when you've got this feeling of being a part of your aircraft, you can use the aircraft capabilities to maximum. The aircraft capabilities are almost unlimited. To say it has a short turning or maneuvering radius is to say nothing. To fly this aircraft is a wonderful feeling. I would say that the Su-27 is the best aircraft I have ever flown. The Su-27 didn't become the best fighter right away. There were many years of tense work, and there were some tragedies as well. But now the flanker's flight is accompanied with such epithets as unsurpassed maneuverability, grace, beauty, and power. And if you want to experience all the power and capabilities of the fighter, don't waste your time. Enter a flight school and choose one of the best professions in the world, the profession of a military pilot. Aerobatic flying. In the Russian language, this phrase also means high skill, great mastership in one thing or another. But for a fighter, aerobatic flying is an ordinary job. This aircraft is performing the Cobra. This very maneuver became the trademark of the Su-27. It's hard to describe my feelings. I'm sure that every pilot would like to perform this maneuver, or at least to sit next to the pilot who makes it. I don't think it's worth becoming just for the sake of performing this maneuver, but someone might have little dreams. To put a pressurized suit and a crash helmet on, oxygen mask, to try a control stick, or try to perform a maneuver, even maybe Pugachev's Cobra. I'm sure your desire to become a pilot compromises such little dreams. Different books and films play a tremendous role in my choice to become a military pilot. When I was young, I used to read a lot of adventure books. One of my favorite was Two Captains. I like films on the World War II, where the main characters are military pilots. I'm also fond of a model airplane flying. Like in every profession, it's important to be on the edge. The profession of a pilot comes first in aviation, and I always wanted to be not just a pilot, but a fighter pilot. I'm married, I have 2 children. My son is 12 and my daughter is 1.5 years old. She knows I'm a pilot. Her first word was Dad. When she sees an aircraft, she points at it and shouts, "My dad, my dad." My family, my wife, and the children like my profession very much. Especially my son is very proud of me. He is proud that his father flies the best aircraft in the world. Even my mother-in-law is proud that her son-in-law flies the best fighter. Everybody are proud. The Su-27 pilots using aviation slang are simulating the oncoming flight.
91, атакую. Вилку вправо. Начали. Огонь. 091, атакую.
The Su-27 cockpit is spacious enough for a pilot of any size. Though there are quite a few devices and switches in the cockpit, their layout is standard for any fighter. This is flight navigation data, engine monitoring instruments, and fuel gauge. The Ekran system, which displays some data control and emergency signals. This is the control stick, with many buttons, including automatic system control button and armament control button.
Вижу двоих на месте. Атакую. Винт вправо. Начали.
This red button turns the automatic control system off. This is a trim button. This is a horizontal alignment button. This button provides aiming during aerial combat. This is a missile launch trigger. Here is the weapon selector for close aerial combat and long-range combat.
Наблюдаю двоих. Огонь. Атакую. Крышу вправо. Вижу двоих. На месте.
This device shows me which type of weapon threatens my aircraft and from which side.
Меня облучие. Разворот вправо на 180. Узел влево. Начали. Вижу двоих. Пуск.
On the left, there are engine throttles. There are two throttles, left engine and right engine. They are in idle position now. My pilot controls these engine throttles. This is a thrust rating position. To switch to afterburning mode, I lift the knob and move the throttle. The same when I want to switch the afterburners off.
Краб влево начали.
There are two engines installed on the Su-27 aircraft. This is very important in terms of redundancy. For example, the MiG-23 or MiG-21 are single-engine aircraft. Sometimes in emergency situations, the pilot has to shut the engine off. The best outcome in this situation is the pilot's ejection and loss of the aircraft. Fourth-generation aircraft, such as the Su-27, for example, are equipped with two engines, which is very good. The Su-27 has an adaptive wing. These deflective surfaces do not have fixed deflection. The wing gets adapted to ram. Depending on the speed, altitude, or angles of attack, the wing takes the most advantageous aerodynamic shape for current flight mode. Due to this feature, the Su-27 aerodynamic characteristics are improving. I would say the wing is breathing as if it were alive. This is one of the Su-27 features no previous aircraft had before. The Su-27 aircraft is equipped with a radar sight during aerial combat or target interception. This radar sight plays an important role. It can detect multiple targets from long distances. It also tracks visual targets in close air combat. The radar sight can lock multiple targets. Radar is the core of the radar sighting system. The radar allows detecting fighter-type air targets at a distance of up to 100 kilometers. A target can be detected with the optical detection station. This peculiar eye is installed directly in front of the cockpit canopy. This system comprises an infrared search and tracking system and a laser rangefinder and target designator. Tracking range of the optical detection system is less than that of a radar. But there's one advantage. The optical detection system can detect a target without exposing it to radiation and therefore to perform a covert attack. Due to the helmet-mounted display in close air combat, all the data can be fed to the missile's homers. All these three components, the radar, the optical detection station, and the helmet-mounted display, are parts of a single weapon control system. Head-up display, which is installed in the Su-27 cockpit, is a very useful device. On this display, a pilot receives all the necessary information. It can be flight navigation and target data. It also gives him information on the radar functioning mode. This is a very easy-to-use head-up display, which does not distract pilots during close air combat or target interception. When firing the cannon, two curves on the indicator represent the impact zone. Depending on the aircraft maneuver, these curves change their curvature.
Наблюдаю одного. Подтягиваю нисходящее. 92, выход вправо. 091, пара, работу закончили.
Выпусти шасси.
When pilots begin flying the flanker, they usually start with combat trainer version of the aircraft, which is called the Su-27UB. It's common practice. Almost every single-seat fighter has its two-seat trainer version. But it's worth saying that all the previous two-seat trainers were inferior to single-seat aircraft in combat performance. In order to arrange a space for the second crew member, it was required to remove either the radar or some armament. Plus, a view from the second cockpit was far from being perfect. The Su-27 combat trainer version proved that the flanker has a great potential for further upgrades. Combat capabilities of the Su-27UB are the same as of the single-seat version. More than that, for long-distance flight, it's more preferable to use the two-seat version. In this case, the crew workload is significantly reduced. My longest flight lasted for 15 hours and 42 minutes. I spent nearly 17 hours in the aircraft cockpit. It was quite difficult to sit in the cockpit for such a long time. During the flight from Moscow to Komsomolsk-on-Amur and back, we performed 4 air refuelings from IL-78 air tanker. 2 on the way to Komsomolsk and 2 on the way to Moscow. The transfer flight, which he described in the interview, was performed exactly on the Su-27UB. Igor Vortintsev was the second crew member, and Nikolai Sadovnikov was the aircraft commander. The flight was made on June 23, 1987. Little before that, this crew flew to Graham Bell Airfield. This is the most remote airfield in the north of Russia, based on Franz Joseph Land Archipelago. During these transfer flights, the air refueling system was tested. Shortly after the tests, the system was used on the aircraft new versions. It's easy to notice that some Su-27 versions have little additional wings in front of the main wing. These little wings are called canards. Canards allow to improve stability and controllability of the aircraft. But as it often happens in aerodynamics, some negative effects come alongside with advantages. In case of the canards, there is a drag increase which results in the maximum speed reduction. So don't expect to find canards on every aircraft. Canards are used on certain aircraft where they are really necessary. For example, in the early 80s, they decided to upgrade flanker with a new radar set. It was an advanced radar, but heavier than the previous one. Therefore, configuration with canards was chosen for a new aircraft. The aircraft nose part weight was increased, which required strengthening of the nose landing gear leg. 2 wheels instead of 1 were installed. With a new radar, the fighter could efficiently detect ground and sea surface targets. Apart from air-to-air missiles, the air-to-surface missiles became part of the aircraft armament. The Su-27M was the designation of the new multi-purpose aircraft version. But this version was developed when the country was going through hard times. In the early 90s, most of the aircraft projects were closed. The Su-27M wasn't put into service. But the carrier-based version of the aircraft was far more lucky. In the Soviet Union, the history of carrier-based aircraft began in the 70s. In the middle 80s, the Soviet Navy had 4 aircraft carrying cruisers. They were a base for Yak-38 carrier-based vertical takeoff and landing attack aircraft. The NATO aircraft carrying fleet was a different story. There were more than a dozen aircraft carriers, carrier-based aircraft of different types and purposes. That was indeed an efficient tool of world politics. Therefore, the Soviets decided to build new aircraft carriers and new carrier-based aircraft. Among these aircraft were the Yak-44 radar picket airplane, Yak-141 supersonic vertical takeoff and landing aircraft, MiG-29 and Su-27 carrier-based versions. Each of these aircraft had a different destiny. The Yak-44 wasn't even built, and Yak-141 became no more than a prototype airplane. As for the MiG-29 and the Su-27, there was a real rivalry between them to become a carrier-based aircraft. Eventually, only one aircraft was chosen for an aircraft carrier. That was the Su-27K, where K stood for carrier-based. Later on, this fighter became known as the Su-33. The Su-33 project was started even before the Su-27 mass production began. We had a small group of designers who worked on carrier-based aircraft. But the real full-scale work on this project began in 1983-1984. We had a goal to develop such a system which could break up enemy raids and to provide air defense of the ship main attack force. This main attack force would include an aircraft carrier. We had a lot of meetings in which Soviet Fleet Admiral Gorshkov took part. This main force was expected to consist of several aircraft carriers. It could have been a large-scale program, but with disintegration of the Soviet Union, our finances were cut short. Anyway, we built approximately 30 production aircraft under this project. These aircraft are still in service nowadays. Let's have a closer look at the Su-33 to define some features of carrier-based aircraft. It's obvious that the carrier-based aircraft have to be relatively compact. That is why most of the aircraft of such type have a folding wing. It's a challenging engineering task to design and manufacture such a wing. First, it's required to provide the sufficient structural strength. Second, there are fuel tanks in the wing, so their total capacity has to be retained to a maximum. The designers also have to take into account the control system and missile suspension points. Takeoff is another problem to solve. It's obvious that a deck length is much shorter than the length of a ground runway. Takeoff run on the aircraft carrier is 100 meters only. More than that, the Su-27 carrier-based version is heavier than the original aircraft, and this extra weight somehow affects the carrier-based aircraft flight performance. So the Su-33 wing was designed in such a way that it created higher lift as compared to that of the Su-27. This was achieved due to the improved wing high lift devices with the flaps installed in addition to flaperons. To increase flight distance, the Su-33 was equipped with an air refueling system where, with the help of the system, the aircraft could be refueled either from a special tanker aircraft or the same Su-33. The most crucial task for a Navy pilot is a carrier deck landing. For a safe deck landing, the aircraft landing speed must be as low as possible. But at low speeds, it's much harder to control an aircraft. This is when the powerful high-lifting devices of the Su-33 wing become useful. Due to these devices, the Su-33 is stable and has good controllability at low speed. In general, the approach path of the aircraft carrier deck differs from the traditional one. When the aircraft approaches a ground-based airfield, its descending path has the so-called flare-out portion. This is where the approaching aircraft reduces its descending vertical speed to make a softer landing. For landing on the aircraft carrier, there's no flare-out portion, so the landing becomes more accurate. Accuracy in this case has a critical importance. As a result, an aircraft lands on the deck at higher vertical speed. In order to stop a fighter at the short deck, there's an arresting hook installed on the aircraft. This hook picks an arresting gear cable. However, there's a big load on the aircraft structure. Ensuring the fighter's structural strength caused an increase of the aircraft weight. Speaking of all these technical details, let's not forget about the man in the cockpit. When the carrier-based aircraft lands on the deck, the pilot experiences a high G-load. At the same time, he has to keep the situation under control. And in case of some emergencies, like arresting gear failure, the pilot must have enough time to take his aircraft back into the sky. All over the world, pilots of the carrier-based aircraft are considered elite. I will tell you one thing, every deck landing is like your first landing. There is a place for fear in our profession. One might call it fear, the other might not. It's an instinct of self-preservation, which is normal. A pilot must have this instinct. If a pilot doesn't have it, it's not good for him. This instinct helps you to be self-disciplined, attentive, and to make a correct judgment. Every Navy pilot, be it a novice or experienced pilot, is told that even if the arresting hook is on, you must not lose your concentration. When there's time for the hook to pick up a cable, you have to be ready to eject any second. When the hooks pick up an arresting cable, it's sort of an unexpected pleasure. This is really an unexpected pleasure. The load, the braking, you feel it with all your body. It's like an extreme. Your head, hands, and legs experience a huge load. For a Navy pilot, it is definitely a pleasure. Deck landing requirements are very strict. The deck landing is the most difficult type of landing. Let's say the maximum deviation from the deck center line is about 4 or 5 meters, but we try to stay within 3 meters. To imagine emotional stress during deck landing, you have to see it with your own eyes. Imagine the aircraft parked at afterdeck. If the approaching fighter is within the limits of maximum deviation, the distance from its wing to the nose of parked aircraft is 3 meters only. There is a pilot in the cockpit of the parked aircraft. There are technicians under the plane. At this moment, the approaching aircraft lands. It touches the deck at the speed of 240 kilometers per hour. Can you imagine this noise, this roar when the engines are in maximum thrust? Then the hook picks up the arresting cable. The Navy operates in the Arctic or the Atlantic Ocean under conditions of strong wind, cold weather, hard rocking. Only brave men can work in such difficult conditions. Their work is very hard, but they're all very qualified personnel. I would compare it to an ant colony, where everybody knows what to do. These people deserve a lot of respect. The history of the Russian carrier-based fighter aircraft is not long. However, there is a Navy pilot school in the country. To a large extent, this is an achievement of Timur Apakidze. He was one of the first pilots who flew the Su-33 and then became a commander. He was teaching other pilots to fly this carrier-based aircraft. Yes, we have such a concept. And we know that Timur Abakidze was the founder of our National Navy Pilot School. In fact, he taught us how to fight, both on the ground and in the air. He founded this new type of fighter pilot school even before the Soviet aircraft carrier went into service. The fourth-generation fighters required a new approach. The aerial combat tactics was changed completely. Therefore, the principles of the combat training had to be changed also. The new combat training was developed, and new maneuvers appeared, and we began to study new tactics. Before starting service on the aircraft carrier, the pilots are trained at the Special Ground Complex. At one time, the Su-33 was tested here as well. For that purpose, initially, they used the original Su-27 land-based aircraft. This aircraft is taking off from the ramp. And this is its predecessor. This aircraft is called the T-10-3. It's the third copy of the initial aircraft configuration. This is a unique aircraft in its own way. It was made not in Moscow, but at the Komsomolsk-on-Amur aircraft plant. It is this plant that became the main aircraft plant for production of the Su-27 aircraft family. There was a lot of work to do. To provide smooth braking after deck landing, a lot of tests were conducted. These included aircraft structural strength and arresting equipment load. In 1983, for the first time in the history of our aviation, test pilot Fostovitz on the MiG-29 and test pilot Sadovnikov on the Su-27 took off from the ramp. These takeoffs proved that takeoff from the ramp is possible and the aircraft behaves steady. When we started to perform the first ram tests, it was always surprising for me how the 30-ton aircraft took off from the ramp, climbing smoothly without losing altitude. More than that, we had to change a Navy pilot manual. In this manual, we had to write down that after takeoff, a pilot must wait 4 seconds. 4 seconds later, the pilot gained the speed. The aircraft is controlled on. It's possible to begin combat mission. The first deck landing was performed by Viktor Pugachev. It was on November 1st, 1989. What camera is this? Is it a Sony? Make one copy for me, please. Next day, November 2nd, the Su-33 made its first deck takeoff. But this takeoff created quite a big problem. When Pugachev turned the afterburners on, the blast fence couldn't hold their power. The fence was partly destroyed by the pressure of the fighter jet blast. The aircraft had to be moved to another position for the takeoff. The frontline bomber Su-34 stands aside from all the numerous Su-27 fighter versions. However, for a person who is not well familiar with different airplanes of the Su-34 relation to the family of the Su-27 aircraft is not obvious, especially that each of these two aircraft has a different purpose. They are also externally different indeed. The idea to develop a new combat aircraft for destroying ground targets emerged in the early 80s. By that time, the Su-17 and the MiG-27 fighter bombers, as well as the Su-24 frontline bombers, were operational in the Soviet air regiments. The main task for an aircraft of such type is bombing and missile air attack at enemy ground targets. For the flight mission, these aircraft usually fly under the cover of fighters because their own capabilities to resist an air attack are limited. But what if one could develop a frontline bomber capable to conduct an aerial combat solo with enemy fighters? For a long period of time, to design such an aircraft wasn't possible. Otherwise, they had to give some aircraft characteristics up in favor of its combat load. This was unacceptable for a frontline bomber. Only with the Su-27 these contradictions were solved. This aircraft met all the requirements. Decent flight range, impressive combat load, excellent maneuvering characteristics. Given the frontline bomber specifics, it was necessary to modify the fighter. Initially, the Su-34 was called the Su-27EB, where in Russian the last two letters stand for fighter bomber. The future aircraft prototype first flight was made on April 13, 1990. The aircraft was piloted by test pilot Anatoly Ivanov. The most extensive structural changes were made to a front part of the aircraft fuselage. Two crew members sit next to each other. To be more precise, they sit side by side. Such arrangement of the seats makes it easier for a pilot and his navigator to communicate with each other during long flights. Total time of the Su-34 flight mission with air refueling can be more than 10 hours. It's important to feel the shoulder of your crewmate during such flight. When they need a rest or something to eat, crew members can take turns. The cockpit height allows the pilots to stand up during the flight. There's enough space to stretch, to squat in the Su-34 cockpit. It's very important for the aircraft crew during long-distance flights to have extra space in the cockpit. Crew members enter their cockpit in quite an original way. To enter the Su-27 cockpit, the canopy is lifted, while in the Su-34, a pilot must climb through the well of the front leg wheel. On March 28, 2009, the president of the Russian Federation, Dmitry Medvedev, made a familiarization flight on the Su-34 aircraft, piloted by Colonel Yuri Gritsayenko. He described the capabilities of the aircraft to the president. The maximum takeoff weight of this aircraft is 45 tons. 45. This Su-34 is sort of a mixture of different aircraft types. It can be used as a fighter because it was built on the basis of the Su-27. It can also be used as a frontline bomber like the Su-24. Its combat potential is similar to a bomber and also has a similar bomb load like the Tu-22 bomber. The Su can perform long-range flights because this aircraft is equipped with an air refueling system. What are the distances? Without air refueling, the flight range is 4,250 kilometers. With one air refueling, it's 7,000 kilometers. Every air refueling increases the aircraft flight range. This aircraft can fly non-stop from Moscow to Vladivostok and back.
646 на взлетную.
646 разрешил на взлетную?
It's also worth mentioning that the total Su-34 bomb load is 8 tons, which is not bad at all for a frontline bomber. Strike aircraft combat missions are very specific. The long flights are often performed at low and extreme low altitudes. It's safer to pass through the enemy air defense system that way, and it also makes the strikes more effective. But portable air defense missile systems and even small arms are a big danger for the aircraft at such low altitudes. Therefore, the Su-34 cockpit is a titanium armored capsule. Other vital parts of the aircraft are also armored, which means this aircraft can also be classified as a ground attack airplane, such as the Su-25, for example. At the same time, the Su-34 frontline bomber is able to stand for itself in aerial combat. This aircraft is very maneuverable, and its maneuvering characteristics are inherited from the flanker. The frontline bomber is equipped with up-to-date air-to-air missiles. The Su-34 maneuvering characteristics are close to those of the Su-27. For a pilot, the Su-34 is like a fighter. This aircraft is very maneuverable and very easy to control. In the end, all the work on the aircraft modification increased its weight. As it was said before, the Su-34 maximum takeoff weight can achieve up to 45 tons. Therefore, the aircraft airframe had to be strengthened, and the new landing gear with rear leg two-wheel bogie was designed. At landing, first the rear wheel touches the runway, then the front one. The Su-34 landing is very smooth. I can't think of any pilot who had a rough landing on the Su-34. This aircraft is like a cruiser. The aircraft became operational in the Russian Air Force in 2006. These aircraft are manufactured in the Novosibirsk aircraft plant. The Su-34 is the aircraft of the near future. In 1999, another Sukhoi family fighter modification was developed. The crew seats arrangement is similar to the Su-34 aircraft. There is an arresting gear in the rear part, which means this aircraft is carrier-based. This is the Su-27 KUB, and its carrier-based combat trainer. With its capabilities, this is an aircraft of a new era. However, by the time we were producing our film, this aircraft existed in one copy. Only time will tell the Su-27 KUB future. But it's not the matter of the aircraft future alone. The Su-27 KUB is another evidence that the Su-27 aircraft has a unique development and upgrading potential. All the more, as the new century was approaching, the Sukhoi fighter family continued its development, and its new versions were about to make their appearance. It's a very difficult and even unique task to design and manufacture a fighter. Thousands of highly qualified specialists are involved in the process. Not every country can create a modern combat aircraft. Day by day, year after year, from one aircraft to the other, the Soviet aviation industry was gaining its experience. The Su-27 aircraft is a perfect example of what has been achieved during these decades. But the world is always changing. The country has also changed. Let's not assess the political events that were happening in Russia in the 90s. But it's worth mentioning that for the Russian aviation industry, those were hard times. But the Su-27 potential was so huge that it was helpful even in those conditions. The Su-27 aircraft family was preserved and further developed. In the 21st century, the new aircraft versions have been designed. By the early 90s, the Su-27 aircraft family has got ultimate recognition and high credibility. These aircraft were in operational service with tactical and naval aviation. As to the air defense units, they were the first to receive these new aircraft. The air defense pilots saw the true value of the Sukhoi 27. Compared to other fighters, this aircraft had a longer flight range. The Su-27 UB two-seat combat trainer had some advantages as well. Therefore, in the late 80s, the Air Defense Aviation Command was eager to have a special aircraft version. A new interceptor was developed on the basis of the two-seat version basis. This aircraft was called the Su-30. The aircraft was equipped with an air refueling system. Electronic equipment was also modified. Now the fighter could be used as an airborne command post. According to the aircraft layout, the air group commander was sitting in the rear cockpit. Having all the air environmental data, he was coordinating interceptors' group reactions. In the early 90s, the Su-30 was ready for mass production. But the economic situation in Russia was so tense that the Russian army couldn't afford purchasing these fighters. Only 5 aircraft went into service. If there is no financial support from the Ministry of Defense, where can we get the money from? So there was no financial support and no money at all. We didn't receive our salary for 5 months. When the Soviet Union collapsed, we were not thinking of aircraft designing, but how to survive in such conditions. The military people said the Su-27 could not be sold abroad. It was only for the Russian Air Force. We were arguing with them that our people needed work. Mikhail Semenov was insisting that the only way out of the situation was to break into the world market. Mr. Semenov was one of the initiators of this idea. When we started to work with the Chinese, they paid us with their down jackets made in China. But then those jackets were stolen from us, and we decided that next time we would accept only dollars. Otherwise, we wouldn't have been able to survive. Those who were late to use the possibility and did not have sufficient experience simply became bankrupt. At present, only the plants that produce our aircraft for export are still in operation. These are Komsomolsk-on-Amur and Irkutsk plants. They have not only preserved their personnel and technology, but made a lot of progress. They have new up-to-date equipment and did not lose their personnel. This is very important. Today, the promotion of these products to India, Algeria, Malaysia, and the Su-30 versions export to China, Vietnam, Indonesia, Venezuela have provided the main export potential for our company. Over the last 15 years, more than 450 Sukhoi aircraft were exported. This gave us a possibility to discuss not the past achievements of the Sukhoi company, but its future. Speaking about its history, it's worth mentioning that Sukhoi is a company with a high level of technical, staffing, and production potential.
Технического, кадрового, производственного потенциала.
Depending on the customer's country, the specifics of the version, some letters were added to the fighter name. The Su-30, MKI, MKK, and MKM. At the customer's request, the Su-30 fighter interceptor has turned into a multifunctional fighter. In other words, this aircraft became a combat system that successfully attacks both air and ground targets. Traditional pointer instruments were replaced by multifunction color displays indicating all the required information to the pilot. This information includes route instructions, aircraft systems condition, or flight parameters. The data from the aircraft radar and weapon control system is also displayed. Such fighters belong to the 4+ generation, which is the 4th generation fighter with new avionics and armament.
Отлично!
Great! It's worth mentioning that apart from different flight instruments, the Su-30 export versions also have different structural features. Let's take a detailed look at the Su-30 MKI for the Indian Air Force and the Su-30 MKK for China's Air Force. The Indian version has canards, while the Chinese version doesn't. The main difference of the Su-30 MKI is perhaps its power plant. The fighter engine is equipped with pivoting nozzles that allow to change thrust vector direction. The Su-30 MKI aerobatic flight is always of special interest to spectators. Double twists, minimal turning radiation, station keeping in the air. In this particular case, it's a concept of a high-level maneuverability. Practical work on the thrust vector control was conducted since the late 80s. Apart from the version with round nozzle, the power plant with flat nozzle was worked through. The Su-27UB aircraft was used for the system testing. A special flying test bed was created on the basis of this aircraft, and some flight tests were conducted. Mikhail Pogosyan was the executive manager of this project. It was a lot of work to do. We were laying scientific and technical groundwork for the fifth-generation aircraft creation. Not all of the solutions were implemented. We flew the flying test bed with a narrow nozzle, checked the controllability. A flat nozzle gave a chance to considerably reduce infrared signature to a back semisphere, which is very critical for an aircraft protection from missiles with homing infrared head. We received very good results demonstrating much lower infrared radiation level. In the West, they conducted some tests as well. In 1990, the X-31 aircraft was designed. It was an American-German cooperative project. Special exhaust gates were turning the jet blast. In 1995, the X-31 was first demonstrated to the wide audience. Those days, only the X-31 aircraft could perform such maneuvers in the air. A year later, a worthy competitor of the X-31 was built. If the X-31 was only an experimental aircraft, the Russian one was much closer to the full-fledged combat aircraft. That was the Su-27M multi-purpose fighter with side number 711. This aircraft is more known as the Su-37. The Su-37 test began in the spring of '96. The project test pilot was Yevgeny Frolov. Shortly, he started to perform such maneuvers on this aircraft that totally changed the concept of an aircraft flight. The Su-37 had one more interesting feature. Instead of the traditional control stick, the aircraft was equipped with a special joystick installed on the right from the pilot. The Su-37 was followed by the Su-30 MKI. The maiden flight of the aircraft took place on July 1st, 1997. The test pilot was Vyacheslav Averyanov. But the European debut of the aircraft wasn't very successful. June 12, 1999, The aircraft crew consisting of Vyacheslav Averyanov and Vladimir Shendrik performs the check flight preceding the Le Bourget Air Show. By chance, the aircraft went lower than it was planned and hit the ground. It was a matter of only a few meters. The pilots had to eject. The things might have been worse if it was not the Su-30 MKI, but some other aircraft. The K-36 ejection seats were one of the key factors in saving the aircraft crew alive. These seats were designed in Zvezda Design Bureau by the general designer Guy Severin. Gone are the days of that flight accident in France. A huge success awaited the Su-30 MKI. For thousands of spectators at the International Air Show in Zhukovsky, the flight of test pilot Vyacheslav Averyanov was awesome and amazing. One of the most spectacular aerobatic maneuvers is a controlled flat spin. It's obvious the concept of high-level maneuverability wasn't implemented only for spectators' enjoyment. First of all, high-level maneuverability is necessary for a fighter in close aerial combat. In close air combat, the one who saw first has an advantage. It is the aircraft high-level maneuverability that allows maneuvering in space, making a faster turn with a smaller radius. During maneuver air combat, the task is to precisely turn the weapon axis to an enemy. What did we achieve due to a controlled thrust vector? First of all, it is flight safety. Now, from the point of view of stability and controllability, such critical phenomena as stall, spin in its usual occurrence, loss of control at high angles of attack, did not exist any longer. We can lose speed up to zero. We can tail slide with a negative speed, keeping up the weapon axis on an enemy aircraft. There are many opinions with regards to whether the high-level maneuverability is needed or not, for how far we need it. This is, of course, a question of tactics, how to use this available means. But we state the fact that this means is already available. This is how the system works at fighter takeoff. Please note, when a pilot pulls the control stick, the stabilizers are deflected together with the nozzles, thus significantly reducing a takeoff run. Our story of the Su-27 aircraft family continues with aerobatic teams which fly these aircraft. Aerobatic team test pilots played a key role in promoting the Su-27 so that this aircraft became well known worldwide. This aerobatic team was organized at the Gromov Flight Research Institute. Hero Russia Anatoly Kvochur is the leader of the team. The team flies the Su-27 and the Su-30 aircraft. The most spectacular part of the aerobatic flying is a head-on approach. The approach speed might reach 1,500 kilometers per hour. Very impressive are the Su-27 classical aerobatic maneuvers such as Cobra and tail slide. Sometimes these maneuvers are performed in pair. This is the Russian Knights, the Russian Air Force aerobatic team. The Russian knights discharge flares saluting to the spectators below. Beautiful, isn't it? In combat conditions, these flares mislead enemies' radar homing missile seekers. You can see how technicians are installing new flares in the aircraft. The most difficult part of the night's demo flying is the formation roll. From the ground, it looks like all the aircraft roll as one. But each aircraft flies on its own unique path. Russian Falcons aerobatic team represents Lipetsk Air Base Combat Training Center of the Russian Air Force. The Falcons demonstration flight includes elements of combat dogfight. Note that false canopies are painted underneath the aircraft fuselage. This is to confuse enemy pilots so that in close aerial combat, they hardly understand which direction the fighter is moving and from which side it is going to attack. Pilots have their own task as well as technicians. That's how they pack the drag chute. Lipetsk Air Base with its Falcons aerobatic team is a link between aircraft designers and military units. This is the place where military pilots first meet the new aircraft. The first upgraded Su-27 aircraft were delivered to this place. Now the fighters can attack ground targets more efficiently. The Su-27 aircraft is a production upgrade Su-27SM. For foreign customers, the export version, called the Su-27 SKM, was developed. So much we've learned about the Su-27 aircraft family, and we've seen these fighters from different points of view. But there's another interesting aspect that very often can hardly be seen. The pilot's actions before and during the flight on the Su-27. When the technicians have prepared the fighter for takeoff, the crew arrives. Before taking his seat in the cockpit, the pilot makes a visual inspection of his aircraft. It has nothing to do with the pilot's superstition. According to official documents, an aircraft must be visually checked before every flight. This is routine for both test and military pilots. The pre-flight inspection begins with the pitot tube. It's important to check its mounting, all the holes that have to be free and clean. The cone nose part is also checked. But most important is the air intakes inspection, because they are the aircraft heart. If there are more suspensions, their availability is also checked. The wing is being examined. Pilots have an obligatory tradition to kick a wheel when making an inspection. Technicians ask them what they want to check with such a pressure on the wheel. Anyway, the pilots stick to this tradition. Everything is in place. The nose strut is being examined. There is alcohol in this tank. After these procedures, the pilot accepts the aircraft, puts his signature in the technician's logbook, and can start up the engine and make the flight.
И может запускать двигатель и выполнять полет.
As soon as the pilot takes his seat, he fastens the harness. Seemingly simple, this procedure is critical enough because the belts must not restrict the pilot's movements. And at the same time, they must hold him tight when he performs aggressive maneuvers. Russian Knight's aerobatic team pilots are checking their belts tension. Then communications and life support systems are connected, followed by the aircraft systems check. The pilot starts the engines. When he makes sure that the engines work fine, the pilot checks the efficiency of the aircraft controls by moving hard the control stick and pushing the pedals. Here is Vyacheslav Averyanov getting ready to fly the Su-30 MKR. When the canopy is closed, the cockpit automatically gets pressurized. The takeoff preparation process is fascinating. Harsh, a little bit intoxicating smell of aviation kerosene. And the sound, low roar of rotating turbines turning into a shrill hissing. The hypnotizing movements of controls. The aircraft springs to life as if it were alive. Takeoff clearance is given and the aircraft is taxiing to the runway. The pilot provides maximum engine thrust, releases the brakes, activates the afterburners, and the aircraft starts its swift takeoff run. As soon as the fighter takes off, the pilot retracts the landing gear using a special control. This is a video of some aerobatic maneuvers taken inside the cockpit and from the ground. The roll, the Cobra, the tail slide, round of applause. Having admired the beauty of the flight, it's worth talking about the Su-27 combat power, that is, the fighter armament. We'll start with an aircraft cannon. The Su-27 aircraft is equipped with a Gusha 301 cannon. The 30mm single-barreled cannon was developed by two Russian designers, Gryazev and Shipunov. Its ammunition load is 150 rounds. The cannon efficiently hits air targets over a distance of up to 800 meters. The Su-27 missile armament initially included the R-27 air-to-air medium range and the R-73 short-range missiles. The R-27 missile launching range is up to 80 kilometers, and the R-73 missile launching range is 30 kilometers. By the way, the R-73 is the smallest missile in the Su-27 missile armament. Its weight is a little more than 100 kilos. The R-73 Close Maneuver Combat Missile is a unique missile that over many decades has been considered the world's best one in its combat capability and efficiency, combined with the aircraft sighting systems. With the fighter improving, new missiles were designed. The RVVAE air-to-air missile. It can be recognized by distinctive lattice rudders. The launching range of the missile is 65 kilometers. A pilot doesn't have to constantly keep his enemy in aiming sight. At the final stage of the launch, the missile, using its active radar homing device, will track and destroy a target. In close aerial combat, the missile fire and forget capability is used. This is really a very important aspect in air combat missiles creation. The missile is equipped with a small radar, which independently localizes the target. The pilot doesn't have to do anything after the target is locked with the missile. The aircraft can then make free maneuvering and fly away from an enemy. The enemy will be hit automatically. And now the Su-30 MKK is launching two Kha-29 missiles. These are air-to-surface guided missiles. The Kha-29 is designed to destroy surface reinforced targets such as concrete bunkers. The missile warhead weight is 320 kilos, and the launching range is 10 kilometers. Launch. Hold it, hold it. Got it. This is the Kha-31 launch. The missile is designed in two versions. One is an anti-ship missile, the other version is designed to attack enemy radars. The targets can be destroyed over a distance of 110 kilometers. Another air-to-surface missile is the Kha-59M. Unlike other missiles, which are equipped with conventional solid engines, the Kha-59M missile has a low-consumption, small-side turbojet engine. It's designed to destroy key targets which are well protected by air defense facilities. The launching range of the missile is 115 kilometers, so the fighter doesn't have to enter air defense area. The fighters can also attack surface targets with aircraft rockets. The Su-27 aircraft family armament consists not only of cannon and missiles, airborne bombs. Apart from standard free-falling bombs, the airborne guided, or the so-called corrected bombs, are also used. The probable circular deviation of such smart bombs does not exceed 10 meters. You must admit that for 1.5-ton bomb, it's not a bad result. As to unguided bombs, their release algorithm depends on the target type. This is the Su-34 bombing. February 19, 2008. Everything is ready for the new aircraft first takeoff at the Flight Research Institute airfield. This is the Su-35 fighter. The first flight is like an aircraft birthday. This date will appear in aviation reference books as a reference point of the aircraft flying history. Hundreds of test flights, moments of good luck, disappointments, and new victories will come later. But for now, this first exciting flight is a unique result of the designers, engineers, and workers' intensive work. There were so many such memorable days at the airfield in Zhukovsky. It was from this airfield that in May 1977, test pilot Vladimir Ilyushin took off the T-10 aircraft, which became an ancestor of the Su-27 family. Now, in the new century, test pilot Sergei Bogdan is getting ready for his first flight on the Su-35. These two events are so similar, though they are separated by decades. lots of emotions during the first flight. They are mostly connected with responsibility. It's exciting to see so many people near the aircraft. Over months before the aircraft's first flight, there is practically not a single minute without 20 to 30 people near the aircraft 24 hours. One understands that this is an enormous work of many thousands of people, and the objective is to act with no worry, deliberately, composedly, in order not to let anyone down. Nearly 40 years have passed since the first drawings of the future Su-27 fighter was made. This is the Su-35. The aircraft embodies all the best results that were obtained during those years. The Su-35 capabilities are even higher than those of the Su-27. First and foremost, it concerns the weapons. The aircraft sees better, differently, and for longer distance. It has quite new missiles, better control system. It appears there's a way for even more improvements. The fighter cockpit is designed to the latest standards. A pilot receives all the necessary information on two big color displays, 15 inches each. The Su-35 aircraft engines have pivoting nozzles. The maximum thrust of each engine in full afterburner is 14.5 tons. It is 2 tons more than the predecessors had. Integrated control system helps a pilot through all the flight stages, from taxiing to making flight maneuvers. In engine failure at takeoff, let's say, the process is very rapid. The heading change dynamics is also very fast. For the aircraft not to move aside, the system of parrying this engine failure is automatically activated, and with the help of thrust vectoring automatic engagement, the aircraft corrects this movement and continues, let's say, takeoff quite safely. The Su-35 doesn't have a traditional air brake. It was replaced by the rudders, which turn outwards to provide aircraft braking. Now a few words about the weapon control system. The core of the system is the Airbus radar station. It is the radar with so-called phased array. They scan the area in electronic mode. This mode is much faster, and it allows to perform simultaneous attack on multiple targets. Aerial target acquisition is 400 kilometers. The Su-35 armament also includes both all the above-mentioned armament and new advanced long-range missiles. The Su-35 is the 4++ generation fighter. This means that structurally it's the further development of the Su-27 aircraft, but the Su-35 is superior in its capabilities as compared to the Su-27. The Su-35 aircraft is a step towards the new 5th generation of Russian fighters. In the Su-35, we implemented, in fact, the ideology of the so-called electronic co-pilot. If in the Su-30, 2 crew members solved problems, in the Su-35, the second crew member is a computer that allows one of the crew members controlling the aircraft to have information in the most convenient way. This is a step towards a 5th generation aircraft, and of course it'll be easier for the pilots who will fly the Su-35 to switch over to the 5th generation aircraft. 5th generation fighter prototype, known as the T-50, took off on January 29, 2010. The aircraft was designed at the Sukhoi Design Bureau. I don't think that only an initial idea is important in aviation complexes. Of no less importance is what staff possesses this idea. With such a long service life of aviation engineering, it's important that innovations, new technical solutions were laid in the beginning, and an aircraft would constantly be developing, because such service life can be provided only if the product is in progress. If we're talking about the Su-27 project, then the ship-based version, Su-30, Su-34, Su-35, are the results of the complex permanent development. The Su-35 looks very similar to the Su-27 from outside, but in reality, they have nothing in common, as is quite a new complex with different capabilities. This, in my opinion, the reason for the success of this project, success of the people, the company that constantly develops these complexes. For more than a quarter of a century, the Su-27 fighters are in service with the Soviet and Russian Air Force. For 15 years, these aircraft are exported to different countries. During all these years, the Su-27 aircraft scarcely had ever taken part in combat operations. Definitely, it's all for the better. A modern weapon, first of all, must be a weapon for detention. The more efficient such a weapon is, the fewer attempts to encroach upon state sovereignty are committed. Next time, when we watch the Su-27 flight, we shall remember those people who designed, built, and taught this aircraft to fly, to make it the best fighter in the world.